Okay, this is 12.6, and 12.6 talks about subtracting rational expressions with different denominators. Yesterday you did adding rational expressions with different denominators. Subtracting is very similar, almost identical. You have to watch for one little trip me up in midway through. So really this is going to be a little bit of a review here in the beginning. You just look at the denominators just like when we did with adding. And you want to factor them out. So the first thing to do would be to factor out your denominators. So here's my first denominator, x plus 1. Can we factor that anymore? Just like the number 2 you can't factor, this one you can't factor either. It's just simply x plus 1. What about the x plus 2 on the other denominator? Can you factor that anymore? No, you can't do that either. So the highest of each of these is themselves. So your LCM ends up being x plus 1 times x plus 2. Okay, that's that product, means multiply, of every highest power of each factor. So the highest of this one is just that one, the highest of this one is just that one. So together they make that LCM. So now let's go over here and try to make our common denominator. First we have this. What do we need to put down on the denominator to make it this LCM? Well, it already has this, so we just need to multiply it by this. If we do it there, we have to do it up here to make it multiplying by the number 1, because 1 does not change anything. And then we take this guy. We have an x plus 2 already. In order to change the denominator to our LCM, we have this. We don't have this, so we multiply by that. But we make it a 1, so we're not changing anything. And now we can simplify. Well, you can see we can use this denominator on the bottom. X plus 2, x plus 1 is our common denominator. So we can just put only 1 on the bottom, and then we can combine this up here. So when we do that, it's to multiply these out. You can see you're going to have to FOIL, right? To multiply this and this. We could FOIL it right away, or I could write x minus 3x plus 3, x plus 2, and then FOIL it. I'm going to FOIL it right away. So first, x squared, x times 2 be plus 2x. Then my negative 3 times x minus 3x. Negative 3 times my 2 is minus 6. Now, here's the part that changes because of the subtraction part of subtracting two fractions. Everything after this whole thing is subtracted, so you have to put parentheses here because that negative is going to distribute to everything in there. Okay, so this is the only difference that we have with subtracting rational numbers, is this here has to be there. Otherwise, you're going to forget to distribute that to the others. So let's FOIL here. Okay, and now we can combine like terms here, right? And here. Okay, some of you can do that in one step in your brain because you're better than I am. Don't forget that. Whoops, I'm combining this, so I want a negative 3x. And again, that just now is going to stay always over this because we made it a common denominator. I can see that I didn't allow enough room for my next thing. Okay. Now let's distribute this negative. Negative x squared. Then make this a positive 3x and this a positive 4. Now we've distributed it. Now we can drop those parentheses. And now we can combine again. So this and this cancel out. I'm thinking I did something wrong there. Did I? No. And then this and this become 2x. So now we have those done. And this become negative 2 all over x plus 2, x plus 1. Isn't that cool? It simplifies down to hardly anything. What's even cooler is you need to look and see, now after you get it this far, you can see there's something common in both these terms, so you can factor that out and watch what happens when you do that. So it'd be just x. Now don't make this 0. Remember we talked about that in class. You factor out that 2, there's still a placeholder there, okay? And then look what happens. Oh, I guess it didn't happen like I wanted it to. I thought these were going to be canceling out. So sometimes these will be x plus 1, and then you made a 1, so you can cancel them out, but that was not the case here. So that would be your answer. So kind of cool how that all works down to hardly anything. Let's try another one. I'm going to do the one I erased. Y over x squared plus xy minus x over xy plus y squared. So a little different, the denominators, same plan. What's our LCM? Let's factor first, find out. So what can we do to this? We can't FOIL it, right? We can't factor it this way. But if you look carefully, you can see there are common factors. So we can factor out of each term. There's a common x. So remember, this counts. Let's see. This would be x. And then if we factor this x out, this would be y. Okay, those are the two factors of that one. How about this guy? xy plus y squared. You can see it's a similar idea that's going to happen. Leaves x and one more y. Okay, so you see those are the factors there and those there. LCM is the product of the highest of each factors. So here's an x, no x here, so that's the highest. Here's a y, no y here, so that y is the highest. Here's an x plus y. This one only has 1 as well. So that becomes our LCM. So let's go over here. We're going to rewrite this top one, but when we rewrite this, we're going to write it this way. It becomes more clear what we need to multiply by when we rewrite it in the factored form, okay? Because now when I look at my LCM, I can see, okay, I already have that, and I already have that. All I need to do is multiply this by y. And I make it 1. Whoops, not plus, but minus. Okay, and then same with this guy. I'm going to rewrite him, but I'm going to use my factored form. It's the same expression, just factored out. Then I can see clearly that this is there and that's there. I just need the x in this one, but it needs to be x over x. All right, now let's figure it out. Y squared over, it's going to be that denominator that we wanted it to be. You can multiply it out and make sure too. Now, we're going to do minus, this is that same one, right? I'm going to organize it the same way, because multiplication you can put it in any order to organize it so it looks the same, and this would be just x squared. So we have y squared minus x squared. This one doesn't really need the parentheses, does it? Because it's just one term. All over the same thing. Okay, and if you're careful and look at this, you will see that this is a difference of squares. So this is what I was hoping was going to happen in the last one. Difference of squares, remember, is just y minus x, y plus x, right? And the bottom is this. And now you can see what happened, right? This, I should have written the other way. With addition to it, doesn't matter the order. So if I order it this way, you need to try to see it, right? You can see that these two are the same. So that's going to be 1. They're going to cancel. You're left with y minus x over xy. And that's your simplified term. Cool. Okay, so those are some examples for you. The parentheses is what I really want you to remember, because that's one thing you're going to forget. Okay? And then here's one more tidbit that a few of them have that is a good little tip. First of all, how can I write a negative fraction? We've talked about or mentioned this in class before. Some of you have brought it up. This would be a negative 3/7. But a lot of times we put it in front. That's a negative 3/7 too. These are the same expression, okay? But you can also make the 7 negative. It's still a negative. Doesn't matter if you use it at the top, in the middle, or on the bottom. Only one place must have the negative because you put 2, now it's a positive, right? A negative divided by a negative is a positive. But this will help you in doing problems like this one. Because if we add the opposite, we usually go add the opposite. But look at these denominators. Don't be tricked that these are the same, okay? This is a negative x, this is a positive x. This is a negative 7, it's a positive 7. But what happens to my 7 minus x if I make it all a negative? Well, you just distribute that. That makes that a negative 7, and it makes this a positive x. So it really, if I reorganize, is this, which is that, right? So if you strategically add the opposite, don't put the opposite here, okay? Because you can put it on the top or the bottom. It still is a negative number. Let's strategically put it, add the opposite, and it's the whole bottom, right? Here, because this is going to happen now, right? So this becomes this, okay? Because of this, because we strategically put here, it made this flip around. And now we have common denominators, so we can just add those two, and it will equal that. Isn't that cool? Simple, cool, and helpful because it makes it, cleans everything up, okay? I'm going to do one more, and then I'm going to let you loose on your assignment. This one is the same as up here. It's knowing where to put this, okay? Add the opposite here. But if you look carefully, always look. These look like they're the same, but they're not. You see this? It's a negative x, positive x, negative 5, positive 5. So where do you want to put this? You want to make this your negative, right? That's what you want to do. So we're going to do precisely that. We're going to make our plus a negative here, okay, to change this guy. So that will automatically change the denominator to what you want it to be. So now we're at this. Okay, because this switched over, that's going to be here too. Well, this is a plus now, so we really could just leave everything out. Negative 5. See how I have to even think about it. So think it through. So when you change 5 minus x to x minus 5, you're making the opposite. So you're just making this, you're putting this negative right where you want it in this situation. You put it right by this one, okay? So now we can combine and simplify. So x squared plus x minus 9, 2x squared plus x plus 1. So we combine 3x squared. Sometimes it helps to circle like this because you can just visually see where you're at. Just make sure you snag the negative when they're in front, because otherwise you're going to have a wrong answer. Okay? So now you should look at this and you should check to make sure you can't factor this out. Because remember, when we factor this out, sometimes it cancels here. And let's see, I can't just factor a 3 out. I can't, so I have to do something. Will I be able to do this? Let's see, 3x and x, and we need negative 8. So I could do 4 here and 2 here. It would be 2 and 12. No, how about 4 here? That'd be 4x, and 2 here would be 6x. The difference would be a positive 2, so we want the bigger one to be a 2. So we said 2 here. Hopefully you're following me. 4 here. Oh, no, Jeannie. Yeah. 4 times 2 is 8. we need a negative. We need the bigger one to be positive. So this one, because it has 3 here, it's going to be positive 6x. Okay, and then this is going to be a negative 4x, which gives us that positive 2x, which is what we want here. Okay. So indeed, we could factor that one out. And look, what you need to see is when you can factor it out, obviously the book wants you to be able to cancel. So, and that's what you're going to probably guess, that you're going to end up with one of these. So that helps to know this. This one and this one are 1 and cancel. So you are left with 3x minus 4 over x minus 5. And that'd be your answer. Excellent. Okay, I hope this goes well. And I hope you don't have any questions. But if you do, you can email me. I will be on my emails. All right, thanks. Bye.